high availability isn't just about keeping systems running. It's actually about how you detect failures, how you replicate data across complex cloud environments, and how you prevent catastrophic scenarios like split brain conditions that can corrupt your entire database. For enterprises running mission critical workloads like SAP HANA or SQL Server, wrong HA architecture can be more dangerous than no HA strategy at all. And in this episode of Mission Critical, we have with us Matthew Pollard, Customer Experience Software Engineer at SIOS Technology, to discuss what enterprises should actually ask their HA providers before they commit to a solution. Matthew, let's start with monitoring. How does SIOS monitoring capabilities differ from other HA solutions in the market, and what specific type of failures can your systems actually detect?
Right. And this is a really important question to ask because you want to understand exactly what value you're getting from the solutions you've chosen, the providers you've chosen to work with versus what else might be available in the market. With SIOS products, what we really value is the versatility of applications and system components that we do monitor and protect against various failures and provide redundancy for failovers against various failures. They can exist at the application level, which we have resource kits for handling. They can exist at the network level. We monitor system reachability and network availability. They can happen at the storage level. We provide both monitoring of the availability of the storage as well as replication of the data on that storage across nodes for consistent access. So making sure that it's not overly specialized in one area, such as just monitoring the system availability while foregoing some of the application level failures is important.
When it comes to replication, especially in disaster recovery scenarios where you need to replicate across cloud regions and availability zones, what options do SIOS customers actually have, and how do you help them choose the right replication strategy for their specific needs?
So first off is understanding the challenges that are at play, especially as you mentioned in disaster recovery scenarios where one system tends to be very geographically separated from the others. While that's good because you have higher protection against larger scale failures, the simple physics of it is that it just incurs performance overhead. It involves delays and such. So from a SIOS standpoint, we have various tunings we can provide to allow remote systems to catch up when available. We have different types of replication, synchronous versus asynchronous, where you can trade some of the performance overhead for a slightly lower protection threshold, which is typically acceptable in a disaster recovery scenario because it's only used as a last resort, typically when none of the other systems are still available. Maybe a whole data center goes down. So those are the things that we provide, and those are the things you should be asking your HA provider about. What options do we have? Usually there's a large amount of tuning parameters that are available to you if you can explore them, and understanding the options that can meet the challenges you have in your environments, depending on just how far apart the systems are, how often you want to use your disaster recovery, maybe as part of drills or as part of maintenance procedures, is very important.
Most HA solutions monitor server health, but what about the broader infrastructure picture? Does SIOS monitoring extend to storage I/O performance and network path availability as well, or is it primarily focused on compute resources?
Right. There are components in the SIOS products for network availability, both specific to what certain applications will require, reachability of different services across different nodes, as well as more broad components such as targeting network components, IPs, and such used for connecting to applications or between different clusters even, or traffic across nodes, replication traffic, communication, heartbeat tracking, as well as monitoring the storage and make sure that it's available, it can be written to, it can be read from by the applications so that they can both read the data to perform the queries, the monitoring that they need to do, write to it to make the updates as needed, and also to make sure that replication is working appropriately.
This is a question a lot of cloud architects ask. Cloud providers already offer redundant storage options built into their platforms. So why would an enterprise need a third-party SAN-less cluster solution like SIOS? What specific gaps are you filling that native cloud HA can't address?
Right. And that's an excellent question because if you are using any HA solution in a cloud environment, you're getting both of them. So it's good to know what each one is actually providing and what it's focused on. And in the cloud level, they tend to be focused primarily on the thing that they are providing for you, which is just the infrastructure that you host your applications and your systems upon. But there's this whole other layer that's equally important at the application level, where products like SIOS high availability products come in and monitor and protect and orchestrate switchovers, failovers, monitoring, enabling maintenance on those applications or on the systems themselves across the different nodes in a cluster, which is not something that is covered by the level of redundancy at the infrastructure and hardware level that cloud providers offer.
Now let's talk about split brain scenarios, as they are one of the most dangerous situations in high availability architecture. When a network partition occurs and you have data corruption risk, how does SIOS architecture strictly prevent those split brain conditions from happening in the first place?
Yeah, and that's certainly a high concern, especially when you are replicating data across nodes and you get into these split brain situations and you start running the risk of divergent data, and making sure that the right system is the source when all of this is resolved is imperative, because if you have divergent data on just one of the nodes while one of them is correct, you don't want that to replicate potentially bad data over good. So in SIOS products, we have various measures for both automated split brain resolution and consistent tracking of the proper source node across systems. And this can be used in a couple different ways, such as the aforementioned automated resolution, user-facing advice and resolution for this node is being tracked as the appropriate source prior to all of this happening, or for validation and fencing, where if not all nodes can agree on what the actual source is supposed to be, what it used to be, then we can stop that scenario of a source with bad data overriding a former source that still had the correct data by being able to fail those validation checks that we have put in place in the products and alert the users to the situation, as well as a variety of resources available to end users for how to approach these situations and resolve them.
Moving a complex database like SAP HANA or SQL Server during a failover is incredibly complicated. There's boot order dependencies, service placement requirements, application-specific configurations. How does SIOS ensure that secondary nodes come up in the correct sequence and meet all those vendor-specific requirements during an actual failover event?
Right. And like you said, it's complex and there's a lot of moving parts in these types of situations. So there's not just one answer to that question, but there's multiple measures for how SIOS products approach making sure that this is correct. The first one would be the use of the SIOS, what we call application recovery kits, ARCs. And what these are, they are software kits in the SIOS products that are made to protect very specific resources in your landscape. And they are engineered and designed with the needs of those resources in mind, following the best practices of the original software vendors and providers. So they take into account the different components that it needs to function correctly, what needs to be present, what needs to be moved around with it, and handles as part of monitoring and protecting and administering that resource, that application, that database, the related components as well. There's also interplay between different types of resources protected within SIOS products, like the IP that might be used for connecting to it, the storage that has to underlie the database, and they have their own very specific checking and monitoring and failover capabilities that are implemented alongside it. And then dependency systems that are put in place, usually automatically when you create the resource, or you can change them up based on the specific needs of your environment, to make sure that they all come up together, they go down together, they move between servers together, and they're always online on the same system at any given point in time, so that the applications have what's needed of them, as well as being able to fill in perhaps the little gaps that might exist unique to your environment with fully customizable resource types through use of generic applications where you can define your own scripts, and quick service protection where you can identify services on the system at the operating system level that do need to be online together, like if you have additional extra components or things that your organization has developed yourself that need to be running.
Matthew, thank you so much for joining me and walking us through these critical considerations for high availability architectures. And for those watching, if you are evaluating HS solutions for mission critical workloads, make sure to check out SIOS Technology and their approach to standardless clustering. And don't forget to subscribe to TFR, like this video, and share it with your infrastructure and DevOps teams. Thanks for watching.